world of maritime logistics is entering a new era that is defined by smart technology and sustainability. Modern ports like Rotterdam, Singapore, and Shanghai are no longer just gateways for goods. They are intelligent ecosystems powered by the 4R technologies like AI, IoT, robotics, digital twin, remote sensing, big data analysis, etc. Building on this transformation, two remarkable innovations are now steering the maritime industry toward a fully digital and autonomous future: 5G smart ports and maritime autonomous surface ships, or MaaS. Fifth-generation ports represent a new model of port development that goes beyond traditional automation and digitalization. Unlike the earlier generations that focused mainly on physical expansion or mechanical efficiency, 5G ports emphasize sustainability, intelligence, and interconnectivity. On the other hand, MaaS, or maritime autonomous surface ships, represent the evolution of seaborne transport toward automation and autonomy. These vessels are equipped with advanced sensors, AI, and navigation systems that allow them to operate safely with minimal human intervention. Despite these disruptive technologies, one critical gap still exists in maritime logistics: the lack of effective integration between autonomous vessels and port systems. Today, most ports still rely on fragmented digital systems for communication, scheduling, and navigation coordination. Autonomous vessels, on the other hand, are being developed with sophisticated onboard sensors and AI capabilities, yet they often operate in isolation from port networks. This lack of connectivity creates a digital disconnect between two of the most advanced elements of the maritime supply chain. Imagine an autonomous vessel approaching a busy port. It must coordinate with multiple actors, from port authorities and pilot services to berth operators and cargo handlers. Without synchronized real-time communication, the vessel systems cannot predict traffic conditions, weather shifts, or berth availability accurately. This leads to delays, safety risks, and inefficient turnaround times, defeating the very purpose of automation. Moreover, every port has unique operational characteristics: tide patterns, channel depths, equipment availability, and energy requirements. These factors vary from one port to another and constantly change with environmental conditions. For autonomous ships to adapt to these local conditions, they require continuous access to accurate, real-time port data, something current systems fail to provide effectively. In short, while both ports and autonomous vessels are advancing technologically, they are doing so in silos. The absence of a unified, data-driven environment restricts predictive decision-making, risk assessment, and operational optimization, the very capabilities needed for next-generation maritime logistics. To bridge this digital gap, we propose an integrated framework that connects port digital twins with maritime autonomous surface ships, MaaS, through a unified digital twin ecosystem. A digital twin is a virtual replica of a real ship, port, or system that uses real-time data to simulate, predict, and optimize performance. When combined with maritime autonomous surface ships, it enables smarter navigation, remote monitoring, and safer decision-making without direct human control. There have been multiple studies exploring the implementation of digital twin on MaaS by Hasan et al. 2023, Kinesi 2023, Zia et al. 2024. On the other hand, authors like Clara et al. 2023, Yao et al. 2021 discussed the possibility of implementing a digital twin on port systems. However, we believe that integrating both systems is the key. In this model, both the port and the vessel would have their own digital twins, virtual replicas that mirror real-time operations using live sensor data, weather inputs, and navigational information. The innovation lies in linking these twins together, creating a continuous data exchange between the port and the vessel. Now how it works. 1. At the port. Port digital twin collects real-time data from IoT sensors, AIS, and remote sensing tools, including berth status, crane activity, traffic density, and environmental conditions. This data continuously updates the port's virtual model, allowing it to predict congestion, optimize berth allocation, and adjust operational schedules. 2. On the vessel. The MaaS digital twin mirrors the ship's navigation, propulsion, and cargo systems. By receiving live updates from the port twin, the vessel can adjust its route, speed, and estimated time of arrival automatically based on real-time port dynamics. 3. Instant data exchange. Through a secure communication interface, data from the port twin is transferred instantly to the vessel twin. This allows autonomous ships to see and understand port conditions before arrival, ensuring smooth docking, minimal waiting time, and safer navigation. 4. Predictive synchronization. The integrated system uses AI-based analytics to predict potential bottlenecks, weather disruptions, or equipment downtime in advance. Both the port and the vessel can then coordinate alternative strategies in real time. So the result is a smart, self-learning digital ecosystem where ports and autonomous ships operate as synchronized entities rather than separate units. Now, benefits. First, it boosts efficiency by enabling real-time coordination between ships and ports, reducing waiting time and optimizing operations. Second, it enhances safety, as both ports and vessels can predict and prevent risks through continuous simulation and data analysis. Third, it supports data-driven decision-making, using AI insights to improve planning, routing, and maintenance. Fourth, it promotes sustainability, cutting fuel use and emissions through smarter scheduling and reduced idle time. And finally, it lays the foundation for a connected maritime future, where ports and vessels operate as part of one intelligent global digital network. In essence, this solution makes maritime logistics smarter, safer, greener, and more synchronized than ever before. Looking ahead, this ecosystem could be scaled up to form a national or even regional maritime digital network, where interconnected digital twins share data across multiple ports and fleets. This would redefine how vessels communicate, plan routes, and collaborate globally, making the entire maritime supply chain more intelligent, resilient, and sustainable.